Hello, welcome to this video recording for the law of sines, the ambiguous case. Today we'll be talking about a situation where we are given side-side angle, which is not guaranteed to give us a singular triangle to solve for. We might have two triangles, no triangles, or one triangle, but in order to correctly solve the problem, we need to know what the situation is first and then know what the strategies are to deal with that. So let's begin. So, as I was alluding to, with the side-side angle case, there are actually 6 scenarios to deal with. The first of which are over here on the left of my diagram, and those have 2 situations in which the angle that's given to us is an obtuse angle. So as I look at this, this will be the first situation where I'm given an angle that is obtuse. We'll call it A. The side adjacent to it will be side B, and then the side opposite the angle is side A. All right, so here we have our adjacent side, B, and the opposite side, A. Now in this situation we will look at is where the side opposite the angle, A, is actually smaller than the adjacent side. And so what will happen is we will see that there's actually no triangle created by this. So here is the situation. Again, here's my angle A that is obtuse. The side adjacent to it, in this case I've assigned the random length of 9 units to it, and then that opposite side is less than the 9. It's actually 5.3. And as we'll see, that opposite side just is left kind of dangling in the wind. It isn't long enough to actually connect and make a triangle. And so this is a situation where no triangles are formed. Okay? So that's a no triangle situation, and I'm going to write that down. 0 triangles. The next one is where we have, well, and let me back up for a moment, because the interesting part about this is that this is when that side is less than or equal to B. So let me back up here to that situation, and I'm actually going to make this opposite side 9 units long. I'm going to make it exactly 9, if I can. There we go, 9 units long. And what we'll see is it doesn't actually make any triangle still. It just makes that straight line. So it passes through, and then inside at that angle, using that angle, it isn't long enough to actually connect again over here at the right. And so it never actually makes a triangle. So that's important to note, that it's less than or equal to. Now, with that in mind, a little flipperoonie there, the next situation we'll look at with the obtuse angle is where the opposite side A is bigger than the adjacent side. Okay, so going back to our diagram here, I'm going to make this opposite side, A, bigger than the adjacent side. So A is going to be bigger than 9. Okay, so make it something bigger, whatever, doesn't matter. In this case, I've made it 12.7 units. It can be anything as long as it's bigger than this adjacent side, which is 9 in this case. So you see it swings out to the right here and actually connects to make a triangle, one triangle. And that's true as long as this opposite side is bigger than the adjacent side. I can make it whatever I want, and it will swing out and make that triangle. Now it's smaller, doesn't make it, and some weirdness happens with the program there. Equal to doesn't make a triangle, and now when it's bigger, we see that it makes a triangle as long as it's bigger. So that's the situation when we're dealing with an obtuse angle. Okay, so here we have one triangle that's made. One triangle made. Okay, fantastic. Now, let's look at the more involved situation where we're dealing with an acute angle. Okay, so over here we have our acute angle situation. And the first one we'll look at is this situation where we're comparing it to B times the sine of angle A. Now, why in the world would we do that? B times the sine of angle A. I want you to, for a moment, to think that we're actually dealing with a right triangle. Okay, and I'm going to make this a right triangle here, and drawing in that opposite side. And what b times the sine of a would give us is think about this. The sine function actually relates the opposite to the hypotenuse. Okay? So the sine of angle A would be the opposite over the hypotenuse. Now the hypotenuse is actually side B. So I'm going to erase where I wrote hypotenuse and replace that with B. Okay? Now if I multiply both sides by B, I get this B times the sine of A thing happening. B times the sine of A. And what that gives me is that opposite side in the right triangle. Okay, that opposite side. Now, I'm not going to call that the opposite side. What that actually is, mathematically, we refer to that as the altitude of the triangle. In essence, how tall is that triangle? Okay, this flipperoonie thing keeps happening with my iPad, sorry. So I'm interested in how tall is that triangle. I'm always going to be comparing that opposite side right here, this opposite side, to the altitude of the triangle, the height. Okay, so in this first situation, the opposite side, A, is going to be less than the altitude. Okay, it's less than b times the sine of A, which is the altitude. All right, so let's take a look at my animation. I'm going to make this first off an acute angle, whatever acute angle I want. Here we're going to deal with, I don't know, 65. That looks just fine. And make my window a little bit bigger. 65, and now I'm going to make my opposite side smaller than the altitude. Okay, so side A is going to be smaller than the altitude. So it's going to be like this. All right, anything smaller than that altitude. And what that does again, similar to another situation we saw, it just leaves that side hanging in the wind. It's not tall enough to overcome the height that is formed there, that altitude. Okay? Again, this height from C perpendicular down, that's the altitude, b times the sine of A. So in that situation, there's no triangle to solve. 0 triangles. Okay? Now, here what we have is a situation where this opposite side A is equal to the altitude. It is equal. So if I go back to my diagram here, that opposite side A will be equal to the altitude. Oh, sorry, I want to adjust this. So what it's going to do is it's going to swing down and hit exactly once. So it's not quite equal to it yet. I want to try and stop it so it's just about perpendicular. There, that looks pretty good. So it is going to be exactly long enough to hit once. Boom. If I just get it to sit there, can't get it quite right there. Got to get it to sit exactly once. And we'd have one triangle, and it's a right triangle that's formed here. Okay, one triangle, and again a right triangle that is formed. Okay, so one triangle. Now, the next situation is where this opposite side A is going to be bigger. So A is bigger than that altitude, b times the sine of A, but it is less than this adjacent side. Okay, so it's less than the adjacent side. And this is really a cool situation because it has a lot of applications. So I'm just going to make that opposite side a little bit bigger. It's a little bit bigger. It has to still be less than 9. Okay, the adjacent side. So I'm going to put it at 8.6. So it's still big, still less than 9, bigger than the altitude. And what we see here is it swings down below, but it creates two different triangles. All right, two different triangles. One when it's out here over at the right, and one when it swings in and connects here. Okay, so you'll see it swing in and it stops right here, and it makes a second triangle, this dark blue shaded region. Okay, so there's two triangles that are actually created here. Okay, two triangles. There's one triangle that looks like this, and one triangle that looks like this. Okay, two different triangles. One triangle again that looks like this, and one triangle again that looks like this. Okay, so the last situation is one in which we have the opposite side, A, being bigger than that adjacent side. And in this situation, it becomes irrelevant how big the altitude is, okay? Because by being bigger than this adjacent side, it's absolutely going to be bigger than the altitude. So I'm only comparing it there. So let's see, I'm going to set the opposite side, A, bigger than the adjacent side, B. So bigger than 9. All right, I'm going to make it 12.6. Now when we see the animation, it swings way underneath and then hits once over here, and by the time it comes back around, it's outside of my 65-degree angle, so it never creates a second triangle. Okay, so it's only one triangle that's created, and that's when it contacts over here at the right, because by the time it gets across, it is outside of what I would want for a triangle. Okay, so this is a single triangle, one triangle. All right, so those are our 6 situations. In the next video, please watch the next video. It is going to go through an example of how this actually applies in a problem-solving situation, and we'll solve some problems. So this is the first video. Please watch the second video for the law of sines ambiguous case.